very good evening to one and all. Center of Excellence in Safety Engineering and Analytics, CoE-SEA, wholeheartedly welcomes all our dear participants to week 48 of Weekend Talk on Safety Engineering Management and Analytics. The event is conducted under Azadi Ka Amrit Mahotsav, which commemorates 75 years of India's independence. We begin this event with this beautiful slogan, Asatoma Sadgamaya, Tamasoma Jyotirgamaya, Mrityoma Amritgamaya, praying to Almighty to lead us from ignorance to truth, from darkness to light, and from death to immortality. Let me welcome our dignitaries onto the virtual dais. We have with us Professor J. Maiti, who is the chairman of the center, Professor Obi Krishna, convener of the event, and our expert speaker for the day, Professor Nirjar Dam. He is a structural engineer and a professional at the Department of Civil Engineering, IIT Kharagpur. He is known for his research on structural engineering, structural health monitoring and control, impact studies on concrete, etc. He has done many consultancy and research projects. Presently, he is working on image processing for crack detection and finite element modeling. He was engaged as the chairman, civil construction and maintenance for the infrastructure development of the institute. He also served as the head of the department from 2019 to 2021. He also coordinated short-term courses on training of faculty members of state resource institutes under the National Program of Capacity Building of Engineers in Earthquake Risk Management and has coordinated short-term courses on topics such as seismic reliability and life assessment of structures under the National Program on Earthquake Engineering Education. CoE-SEA wholeheartedly welcomes you today, sir, and we are very privileged to have you. Now, I kindly invite Professor J. Maiti to formally invite our expert speaker for the day. Over to you, sir.
Thank you, Shwin. Thank you so much. Thank you, Professor Dang, for accepting our request and speaking today on a very, very important topic, structural health monitoring. Basically, for the past 2 years, what I have found that a lot of requests from the that structural safety point of view, particularly building safety, earthquake safety, earthquake or related safety, warehouse safety, and also that high-rise building, including hospital safety. So, and across the world, I think in the Department of Civil Engineering, the safety related activities, including IIT Kharagpur, people are doing, and it's a very important topic and important domain for the Center of Excellence in Safety Engineering and Analytics. And you are known to us from the very beginning. So, and Professor Dang is a well-known professor in IIT Kharagpur. His knowledge, particularly in the civil structure as well as its maintenance and the construction site also, it is well experienced by all of us because he was chairman of that CCM, that is Civil and Construction Management, and we have witnessed the level of improvement and implementation that have taken place. Apart from that, this practice-oriented research as well as the high-quality technical and theoretical research, he is an excellent teacher, and he is one of the key member of our center as well as very well-wishers. And Professor Dang, you know everything, so I just request you to help us in developing the center as usual and in future also. And the audience will be immensely benefited with your lecture, and particularly the topic is extremely important for the audience. And as you know that this particular lecture is available on YouTube. So nowadays, what happened that many participants preferring YouTube, they are seeing even after the day of lecture. So with this small note, I request Professor Dang, please give your expert talk, and I welcome all the participants for this weekend talk in this evening.
Thank you. Thank you, Professor Maiti. Thank you, Shuin and Professor Maiti, for a nice introduction. And really, it's my pleasure to be associated with this Center of Excellence in Safety Engineering and Analytics. And obviously, this is a very good initiative of our institute also. I should like to introduce us. First of all, let me tell you, it appears to me this audience little bit away from the civil engineering, maybe. That's why I shall start with something civil engineering thing, and then I shall come to structural health monitoring and all the, and I hope I shall be able to go with a good journey with this particular lecture. So I shall try to give you generally. But the thing is that before that, whenever we talk actually your civil engineering, and that way we say that we have read this one in that history, that seven wonders of the ancient world, the lighthouse of Alexandria, Colossus of Rhodes, mausoleum of Halicarnassus, statue of Zeus, temple of Diana at Ephesus, hanging gardens of Babylon, Great Pyramid of Giza. So there are many more things actually we read in history. But the thing is that very interesting thing actually I'd like to show. It was in July 7, 2007, there was a vote conducted by in Portugal, global votes in Lisbon, and they came up with some kind of new seven wonders. And where obviously that Great Wall of China, obviously that is very old, 220 BC, Petra, Jordan, then Roman Colosseum, Pyramid of Chichen, then Machu Picchu, and Christ Redeemer Brazil, and obviously the Taj Mahal India. And this one actually by Global Votes. Why I am showing this one, you see this particular one, these are the structures actually still standing, whatever way that few of them may be not up to the mark, but still standing. And obviously, because I am talking that with the maintenance, other things also coming into picture. Because of that only this surviving. One thing I can tell you that regarding civil engineering, obviously we consider this one the broadest of the engineering fields. And there are many more things actually come up. And we civil engineers always we take it as a challenge. Whatever others actually implementing, we try to make it in our discipline, particularly in structural engineering. Now, out of the seven wonders, this pyramid was taken out because we say that time feared actually pyramid. So, and also we can say that from the pyramids of Egypt to the exploration of space, everywhere we have seen. Now we are actually exploring Mars. They are also the first thing we are having civil engineering that is particularly, say, for example, surveying. So that way we can see the civil engineering, that one actually very good field and broad field. And we always consider nowadays the sustainable infrastructure. Infrastructure, it has to be sustainable. And there are three aspects. One is that environmental protection. Another one, we call it that economic development. And then obviously, not the least, the one we require that quality of life. So these are the three things that we require. And American Society of Civil Engineers, that is the apex body in civil engineering. And they actually rank the 10 greatest civil engineering achievements. Obviously, one of them, you see that airport design and development. The other one is called dams for your say that water reservoir. You can say also for hydraulic from their power also. Then interstate highway, the one we are having that highways, that golden quadrangle that we can say. Long span bridges, rail transportation, sanitary landfills, solid waste disposal, skyscrapers, wastewater treatment, water supply and distribution, water transportation, everywhere that actually we require structural engineering. Because there is waste water treatment, you can say that is a process, but finally you require certain structures. Similarly, water supply and distribution, you require, say, water tank, you require pipeline. Then another one, water transportation, that is also another big way because the major transport actually it goes through water only. because the bulk actually transport. That I shall come actually next whenever I shall get the opportunity in this particular lecture. So I thought, why shall I go to any other, say Burj Dubai or so many others are there? Why not our institute only? That at least to us it is a strikeable for us. Such a beautiful actually your tower we have, and every day we move around about this tower, you can see. And then obviously we have say dam in Bombay High. This is a very, very old one. The 70s it was made for that oil exploration, oil extraction from sea. Then Sriharikota, that rocket launching. The thing is that what I mean to say, this tower, this particular say, building, at the time of, as you can see in the left, at the time of assembly of the rocket or vehicle, it was within that. After that, it goes back to 300 meters. So you can imagine that a building which has to be moved, otherwise it will be under fire. So at the time of assembly, the structure actually, it will that assembled and then vehicle, and then it will go. I had the opportunity to visit the Sriharikota at the time of assembly. And there, when I saw that at the assembly, that so many wires here and there, all those things, and I was astonished, really it will fly. And the thing is that, and I was watching in the TV that when it will fly, and the thing is that not only that time, in successive years also, that every time actually it is successful, that ISRO mission, that one successfully you can see. Coming to structure or structural engineering, we call it lifeline. Lifeline means actually road. The transport sector, you can consider lifeline. Say, for example, you are having a port. From the port to city, you are having road. Now, the thing is that if the road is blocked, how many days? 1 day, 2 days, 2 days, 3 days? How many days if you can block it so that the city will not suffer? After that, city will suffer. That's why we call it actually lifeline. And the lifeline, that means road is one of them. That obviously we are having different kind of road vehicles. So we are having highways. That one also you can say structure also you can consider. I'm not going to this type of structure, but there also you require certain maintenance. Then railways, that we are having different kind of trains we are having, that starting from the local trains, express, then mail train, then Rajdhani. And obviously that, as I have told you, that ports and harbors, that you say this is the major transport actually, the tons of materials, tons of things actually transport through in these ships or that cargo. Because what happened actually, because no other thing, with the road only, with that we are having very, how many tons? 10 tons, 15 tons, 20 tons, that only we can transport. But here thousands, that 2,000, 3,000 tons, or more than that actually we can transport to that. So that's why that transport sector actually equally very much with that. Water transportation, it is very much required. So from one place to another place, you have to go and you have to have a big actually, you have to say that ship through which you can actually take you thing from one port to another. And obviously, though it is old work, because now it is not that way. So another important part is the runway. Runway, that is the one you can say civil engineering, but if you consider terminal building, the terminal building is such a building where all the disciplines actually involved. Not only civil engineering, that all the things, electrical, then mechanical, then also computer science, everything actually involved in that is terminal building. How big it is, whatever it is compared to runway. Runway maybe say 4 kilometers. But whereas this particular terminal building, you are having so many things are there, and most of the things are mechanized, automatic. So out of that one that we are talking, say lifeline, as I have told you, lifeline either by the air or by the water or by train or rail or by road, that is called actually lifeline. That is the transport system, we call it lifeline. That is the main arteries of our civilization. And what is neck? What do we call actually neck? The neck we call it actually bridges. So I have just taken a few bridges. So obviously the old one, Pamban Bridge, Rameswaram, 1914, it is still working. Then obviously the one, those who are familiar, that is the Howrah Bridge, that you can see that in 1940 actually it is made. Recently, only it has completed 75 years. Then we are having Mahatma Gandhi Setu Patna. This is another type of bridge. Then we are having second Hooghly Bridge. I shall come up with something more with this particular one. And second Hooghly Bridge, that you can say Cable Street Bridge. Now the question is that why I have selected only these 4 bridges, because there are so many bridges are there, and bridges are iconic structures, you can say. Everybody actually, wherever you are located, there you will find out one bridge. And that is the one actually you can say iconic or some kind of your direction. It gives the direction of that particular location. So that way, because I have to be very careful, because one can ask that why you have selected this port, why not you have selected, because there are so many beautiful bridges in our country. And I have taken from our country only because I should have certain kind of bridge, but that is not at all technical. That is non-technical, because suddenly I saw in the internet, because the thing is, the very interesting thing is that these 4 bridges only actually published by that India Post, that 5 rupees stamp. And then I thought it may be my good, that you would say, reason to select them. So these are the landmark bridges of India in 2007 that is published by India Post. So with this actually introduction about civil engineering, the structures, because if you really consider, say, Howrah Bridge, that itself an asset. If we consider other way, forget the thing that you structure all those things. You consider this one an asset, a big asset. Howrah Bridge, second Hooghly Bridge, the Taj Mahal. There are so many structures actually you are there. Those are actually iconic. Sometimes it is heritage, it is very much useful. And that one, very, very important asset, and how to manage that asset, how to use that asset. So this way you can consider that means it is not civil engineering. You think that how you do it, that asset management. That is your another one. It's not the calculation of depreciation, the way we used to do it. You calculate a certain percentage of depreciation, and that way you see whether the machine or equipment, it has to be obsolete or not, that we have to decide. So I'm not going to teach construction planning and management, but I'm talking from the structure, that how it is actually made, how it comes actually. So first of all, it comes the concept. If you really see the concept, most of the cases, the concept, all those things actually, it comes suddenly. If you really would like to do something, the concept is not like that we sit. It can come, and most of the cases I feel the concept, all those things comes in airport, because the big people, whenever they move from one place to another places, most of the cases they meet each other and they exchange their idea, they exchange their concept, that it comes. So from the concept, you have to come to planning, then you have to come to design. When the design is ready, then only you go for tendering. You have to select who will be the best person, who is the best people, best company who will be able to do it, and then award the job, go for execution. When the execution will be over, then you commissioning. That means you have to do the commissioning of that particular one. After that, it will come in the operation. It may be for building, it may be for bridges, it may be for plant, whatever you consider that one operation. But operation and maintenance, both of them go together hand in hand. Just simply you operate, it is not possible. You have to maintain it also. And here it comes the structural health monitoring. We have to see that whether our structure is all right or the one you are using, whether it is all right or not. It may happen different kind of problems. Say, for example, it happened maybe cyclone. Only 2019 only there was a cyclone. And that for that cyclone, actually in one airport, possibly Bhubaneswar or nearby one airport, say for example, that lot of problem with the roof, other things, because the thing is that your wind speed was more than the design wind speed. So then what can be done? So that way, that means so maintenance is an integral part of process. It may happen to earthquake also. So that's why operation, we call it operation and maintenance. These are the two things go hand in hand. And there are few terms actually we use it. We call it AEC, Architecture, Engineering and Construction, AIM, Asset Information Model, because I am talking that particular, it's not structure, it is true for equipment, it is true for any plant also, because the thing is that it is a generic term, but we nowadays we use it here. We consider this one as asset and how to manage that asset. You will find out many more things are there. There are so many committees, so many commission for a particular structure, particularly for bridges, particularly for buildings. Then asset integrity management, asset information requirements, computer design and drafting, international foundation classes, mechanical, electrical, plumbing. Then obviously nowadays we work with the virtual design and construction VDC. That means we would like to do it everything before we construct. We would like to see the everything that way. It can in near future it will come to actually virtual reality, because as you know that you want, that is also another part of that USA Center of Excellence in Civil Engineering. That means everything you would like to see before you construct. So this one, just I would like to give you that I'm not going to teach that one, because the thing is that in structural health monitoring, this is the integral part. I cannot actually just simply, I cannot monitor. Structural health monitoring, one can see it is a pathological. You just test it, yes. But my role, that our role in IIT Kharagpur, our structural engineers, their role not the pathologist. That means that we just test it and give the just with some kind of say general remarks, not like that. You have to finally you have to recommend. That means a physician, the way he recommends what to be do, what to be done. So that is the it is coming say design course, but I am not going to that design course. Only thing I am telling you something allowable. That means whatever we are having that say particular say steel. The steel, if you take a steel rod, how much tension is required to break, that much I know. That is the limit. Now, shall I go to the limiting one? Maybe I shall take 50% of that. That is called how much you will allow the stress. If it is, say, for example, generally we consider, say, 450 Newton per square millimeter, that is the one for steel, or 500 Newton per square millimeter. Maybe I shall use 250 Newton per square millimeter. So that means I have that much of margin. Similarly, that ultimate strength, even if we go for ultimate strength, maybe I shall take 70% or 80%. Generally, we consider 87%. And another one we talk, it's a load and resistance factor design. It is nothing new. We use in economics also. It is something we call it demand and supply. So that means whatever actually load actually coming on the structure, that this much actually expected, and I am not so confident. So let us take little higher. That's why you see that with the expected value, the value that is expected, I am going to little bit right side. That means I am taking little more because I am not so confident. But what about the material? That how much that material, the section, the beam or column or slab, whatever it is, the structure, because slab means where we stand. If you're in the first floor, that wherever you are sitting, that is called slab. The slab, what is the strength of the slab? So whatever I know that this will be able to take, but I am not so confident. I have told, okay, let us make it little less. So that means the demand, I shall expect, whatever expected, I shall take little more. And the supply or resistance, that one, whatever, I know that this much actually will be able to take it, but even then I shall take little less. So that is the one, mu Q and mu R. These are the two values. It may be load, different kind of load. It may be, say, your self weight. It may be, say, your whatever load you would say, including us, your chair, table, all those things. We used to call it live load. And also maybe, say, environmental load, maybe earthquake load, maybe wind load. So those things, whatever are coming in combination of that, that is, if let us call it a mu Q. And resistance, if it is made of steel, so steel, so how much actually it can take? The section you are providing, that section how much it can take. So that is called resistance. So the resistance obviously should be more. And so obviously this particular equation we all know, that is called the reliability index. So beta, so mu R minus mu Q root over sigma square R plus sigma square Q. So that value beta obviously should be greater than 0. And not only greater than 0, it should be a little higher also. Generally, you consider something, okay, beta say 3, if we consider. And on the basis of that, we do all those things. Now, coming to that one here, that nowadays we do, say, for example, drawing, we used to do it, say, in 2 dimension, in a sheet of paper, we just give the drawing. Then we do something in 3 dimension in computer, all those things. And then we call it actually 4D, fourth dimension. That means you do in 3 dimension, you construct it at the same time in time. That means if I do, say, after 1 month, what will be the progress of the structure, construction? That is called actually 4D. If you add cost, that means the top management would like to know that, okay, this is the 3 months after the construction, how much actually you have spent, how much cost actually, how much expenditure was there. So that way we consider 5D. But our objective in structural monitoring, we are talking actually 6D. That means lifetime maintenance planning. So that means you have to see that, as I have told you, that nowadays we call it infrastructure asset management. So structural monitoring is a part of infrastructure asset management. So for that, we require certain kind of things. We have to measure, we have to observe. On the basis of that only we can decide what will be the consequence with respect to that structure. So now we are coming to this point, say common questions on damage. Obviously, the structure over the time, it will be deteriorated like us. Our health also deteriorates over the age. Even we follow a good living. Say, for example, we walk in the morning, we take a very controlled food. Even then, we know that we will become old and we shall not be able to farm on. So similarly, it is true for the structure. It is not because of cyclone. It is not because of fire. It is not because of earthquake. There is a natural deterioration. It will happen the way it happens with every living species. So the question is coming here, what is damage? So what is the cause of damage? So whenever you're talking certain kind of deterioration, natural one, but there are certain kind of things it has happened. It may be due to, say, not maintenance, because the maintenance we have not done properly. And how much, because that whenever we are talking maintenance, it actually matters because there is cost involved. So how many years we shall consider? What is the cycle? Shall we consider, say, for example, 3-year cycle, that every 3 years? Because the thing is that whenever we talk in civil structures, it is not possible overnight. Say, for example, in our campus at IIT Kharagpur, there are so many buildings. It is not possible to maintain that every time. So that means we have to give some time, maybe every 3 years, maybe every 5 years, maybe every 7 years. This is the cycle we consider. So if we consider 3-year cycle, then obviously that your cost will be less because you need not actually do much. But if you take 5 years, then cost will be a little more. But if you take 7 years, then cost will be further more. Say, for example, nowadays, if you see in the campus that roads are being actually being maintained, that they are doing, it is almost, say, 10 years. So that way you can find out that the roads actually really serve well. So that is the one you can see. So the thing is that what is the cause of damage? What can be done to prevent damage? Is damage present? Once present, how are the effects of damage mitigated? How we are going to mitigate that? How fast will the damage grow and exceed some critical level? So obviously that the thing is that, as I can tell you, that structural monitoring is nothing but you can place yourself as a physician. If I ask a physician that I would not like to show you the patient, whatever test you would like to do it, but I shall not show you the patient. So the physician will tell, the doctor will say, no, it is not possible. At least once I shall see the patient on my own eyes. So visual inspection is equally important. That is the first thing, the feelings of the structure. As you can see, I have taken from the one actually recently, we have actually worked on that. So the old, very, very old actually that building. And you can see that, but the middle one actually, just to give it the contrast, that is actually your Howrah station. So the other two actually the same building. And so obviously you'll find out a lot of text. corrosion in reinforcement, the concrete spalling actually that you're spalling. There may be in few places you'll find out excessive deflection. But you are just simply seeing all of them as a qualitative one. So that's why it requires actually high level of expertise based on the visual inspection. So you have to do certain kind of test. So our objective here, the way I have told you that people used to do it, that is you say damage detection, we call it sometimes, that usually carried out in the context of more closely related to discipline that includes, say, sometimes we call it, say, structural health monitoring. Somebody say that condition monitoring, particularly for equipment, other things they do it. Non-destructive evaluation, because I cannot say, for example, somebody, the client has called us and we have gone there, we cannot destruct that structure. We have to do something non-destructive evaluation, non-destructive testing. Then health and uses monitoring system, we have to see, because the thing in the structure actually behaves in a different way. In summer, you have something. In rainy season, you have something. In winter, we are having something. Over the whole year, you will find out that sometimes cracks are appearing, sometimes cracks are disappearing. So that way also changes. So then statistical, because sometimes it goes say statistical. And obviously, we have to go for say something, say damage, a prognosis. That is, so these are the different kind of things actually people work. We cannot work only in one. It is not possible to consider all the area. That's why I've told you in the very beginning, whether that somebody actually they are just simply testing and they're supplying the result. And then from the result, we have to decide whether the structure is all right or not. That is the job of the doctor, you can say. So other way you can tell that when somebody says that I'm just doing the monitoring part only, I'm putting the sensor at different location and then I'm using the values. Then I'm considering that whether damage detection or not. That way you can say that data science, the way nowadays we are doing the data science, that you can also do. And then other one, we call it actually model updating. I am just coming next that what actually with one or two slides I shall tell. And that is another way of doing actually, which comes under structural monitoring also. And obviously, finally, at the end of the day, we have to do the structural health assessment. What is the condition of the health? That finally you have to tell. That means just only your testing will not help. Because the thing is that you have to give the prescription. You have to give the medicine. You have to, what is the solution that you have to provide? So there are many more things we measure, but only thing I have told you a few things. That is one of them, say displacement. Then another one we call it say strain. Another one we call it say acceleration, and then we call tilt. Tilt of that one, say that it moves one way or other. There are many more actually things happen actually that I can tell you. Now, whenever we are talking, say, structural health monitoring, as you can see, this is the one just I have given that different kind of things. That one, so inspection and data collection. That means if somebody says structural health monitoring means only inspection, data collection, that also one can do it. That one group of people will do it. Then performance evaluation, planning and priorities of maintenance. So how are you going to maintain it? Because the thing is that for structure, the main problem with the structure is that structure is very much actually useful. Structure is very much useful. And that way, when the structure is very much useful, because you just simply cannot tell that you vacate it, I shall do it. Whatever we have to do, we have to do all those things. Whatever actually we have to do, planning and priorities of maintenance, that how we are going to do it. Because the thing is that structure will be used at that time we have to maintain. And then what are the repair operations? So regarding data acquisition, just quickly, I shall give you something, say, non-destructive testing. This is the most popular. We do it actually, ultrasonic pulse velocity that we use it. So there is a transmitter and then we receive it. And on the basis of time, we see the quality of the structure. It can be direct, it can be semi-direct, it can be indirect also. It can be indirect also. Then there is another one, that hardness of the surface. From there also we can find out. This is called Smith rebound hammer. From there also we can find out the structure. And as you can see, there is almost a 15% variation. That you can see there is a 15% variation. That means with that error, we have to take a decision. Then we go for actually your say corrosion or corrosion of the steel, because reinforced concrete, other things also corrosion of the steel, that also we can do it. And then sometimes we do it non-destructive, because the thing is that this is a very, very common problem. Almost every week we get a call from different organizations that ought to be done, that for a structure there is some kind of, during construction there is certain problem, and that we have to tell whether it is all right or not. Because the thing is that cost is involved. If you just simply, you cannot replace it. And replacement also, it will take a lot of time also. So like that, actually, we do certain kind of different tests also, we do it. And also we do some kind of hammer test also we can do. That means there is a R wave, something, and then on the receiver also we can find out. These are the different kind of methods. So we do just simply, but most popular sensors that we use it, that is actually your strain gauge. This is called electrical resistance strain gauge. R equal to rho L by A, which you have read possibly in class 11 in physics class. This is the basic things, and we use plenty of electrical resistance strain gauge. We use it. And on the basis, because the thing is that we can just simply put it on the surface, and from there we can measure the strain. Whatever the strain were there, from there we can measure the strain. That way it is very easy to do it. And these are the different kind of foil type actually strain gauge. That I know that there are a few questions. Just please bear with me with the close one, so that I can answer. I'm seeing your questions actually, that I shall come back. And now the thing is that just to give you idea about this, that Wheatstone bridge, that is the one actually we use it. That is also in electrical or physics also you can say. And from here, there actually you can measure the strain gauge. This is the one integral part of the strain measurement that we do it. And this is the part of instrumentation. Another popular one use it actually, you say accelerometer. So strain gauge and accelerometer, that we can actually use it. And nowadays, obviously, we go for wireless accelerometer. Nowadays, we go for wireless accelerometer, because the thing is the accelerometer, use it. And also you should have hand in hand, that is actually your data logger. That means the accelerometer or strain gauge or deflection, whatever you do, you measure it, record it, and then you transmit it to the cloud. That is the basic thing that that we generally do. So obviously the data you have to acquire not manually. You can do it manually also, but not manually, but with the computer, that computed data aggregation. So what is the, obviously the bit, as you can see from the top scale, the divisions are more, so that means precision will be more. The least count is less. Whereas the second one, that least count is actually more. So that way I can use 8-bit, 10-bit, 12-bit, most popular actually 12-bit that we generally use it. And where you can get 2.44 millivolt. But if you go to 16-bit, then the least count can be 0.15 millivolt. The basic objective in structural monitoring nowadays, whatever you measure, either acceleration or displacement or velocity or strain or any other thing you measure, that one you convert it to voltage. And when you convert it to voltage, and that one you calibrate it to engineering unit. If it is strain, you calibrate it. And then you get the strain, and then you transmit. You transmit the data to something that I shall tell you. But the basic thing nowadays, we actually go for vibration-based techniques for SHM. The just only one equation that I can say, that your mx double dot plus cx dot plus kx equal to f. That means mass with something actually acceleration, that is which is time dependent. C, damping. With respect to that, we can consider your say velocity, and k and displacement. So that means if you say that x double dot acceleration is very less, x dot the velocity is very less, that means it will become a static problem. But if it is dynamic, so obviously mass and damping will come into picture. And that way we go see eigenvalue problem, that natural frequency, that eigenvalue is nothing but it can be correlated with the natural frequency. eigenvector, that is called, say, what is the shape of the structure, that also we can do it, and that we can actually make it. And with that, actually, we do it. That means you measure the acceleration, from there you find out the natural frequency or frequency, and on the basis of that, you calculate what is the health of the structure. So the damage localization or quantification means the stiffness, there is a change in the stiffness. We become old, so our actually the force, other things will release. That means our stiffness will be reduced. So that way we call it that change in the structure also, the stiffness will reduce because of the deterioration, because of the corrosion in steel, because of the deterioration, crack in concrete particularly, or in steel, that pure steel, that corrosion, that may happen. Or we can go for static displacement, where we are not going with that. Is you apply the load and find out the displacement, you can see. Or we can go for forced vibration or frequency response functions, that we can do it. So these are the different kind of things we do it for structural health monitoring. Now, what are the different steps? The different steps, obviously, inspection and data collection. Where to provide the sensor, the accelerometer, strain gauge, where shall we put it? Then you do the condition assessment. It can be just nowadays we are doing AI/ML, all those things you are applying, data science also you are applying there. So condition assessment and performance evaluation, prediction of failure performance, planning and priorities of maintenance, repair operations, evaluating alternatives, technical and economic policies. So these are the different steps, one by one we do it. And nowadays we go for actually your cloud-based data collection. That means everything actually can be cloud. That means I can say actually, you can say that your center of excellence can actually make one such framework for cloud-based, where we can actually the sensor automatically use. That is, wherever it is like actually the sensor with some kind of IP address which we can provide, so automatically the data will be transmitted to that particular, say, wave or cloud, whatever. So that means for displacement, for strain, for acceleration, for tilt. Not only that, for actually, for example, you are having temperature, humidity, air pollution. We are actually, one bridge is under construction in Calcutta. We are actually involved with the structural health monitoring also. That what about the your sensors to be used, and then installation of camera for traffic monitoring. With the bridge, that what are the traffic, what are the different vehicles are coming. That also would like to record. So that way, so that we can find out, we can see what is the condition of the structure. So as somebody was telling that once IoT, all those things, this is the thing actually, my thing. I'm telling you, this is actually, I'm using the Raspberry Pi, and that it can do it actually, Internet of Things. The thing is that I did it, this particular one, I purchased from Amazon, then I just connected. This is the one accelerometer. This accelerometer actually I can use it. This one also can be used actually wireless. So this is just to show you, this is in my room only, just I'm telling you that you can have actually your one small that your screen, and everything you can do it in a very much handy. You can do it on your own actually. So if you are interested, that means now this particular one can be actually connected with the cloud locally, so that it will be transmitted, so that anybody can see from anywhere. Now, this particular one, few things I shall tell you actually, just to give you idea that this is Victor Memorial Hall. Actually, recently we are actually that involved actually that they short opinion, because from nearby outside the boundary that metro tunnel will be there. So obviously that Victory Memorial or the curator, he called, he requested us to tell me that whether it will be all right. There will be no problem. Obviously, you can see that particular structure, because from our childhood days, actually, you can say Victoria Memorial. Another one, obviously, you can talk, say Taj Mahal. Very interesting thing is that Victoria Memorial, actually, we go before our marriage, and Taj Mahal, we go after our marriage. So as you can see, these are the two iconic structures. So obviously that how we'll say that this structure is all right or not. Another one I can say in Calcutta, I am also recently associated with this. The thing is that there are 152 cables. The structure, the whole bridge, almost more than 800 meters. This bridge, actually the deck, That is actually that one on the 152 cables. In each side, there are 19, and 19 into, you say, you are having 8, so 152. So these cables, now the thing is that obviously, as you can see, it is just like say muscles. The muscles muscle takes tension. These cables also take tension. So how do you measure the tension? But very interesting thing is that only thing you just the way you sitar or in a musical instrument, the way you give a tension, and if you just give your finger, then you will stroke, then you will find out a beautiful sound. Here the sound will not come because it is not within the 20 hertz to 20,000 hertz, but that one not. But the thing is that from there also you can measure the frequency or natural frequency, and from there you can find out the tension. It looks very simple. So you can measure that periodically, you can measure the tension, measuring the frequency. So as you can see at the top, how beautifully, how very symmetric and very interesting that one, how impressive it is that all the things are coming. And from there, you can see the structure is perfectly all right. Or you can see that whole the structure that you see that secondary bridge that you are having that cable pin. So these are the things actually that how you have to, because this is itself a big asset, a national asset, and that you have to maintain it. For that, there is a commission, Hooghly River Bridge Commission, that Secretary Bridge for that, and they are actually looking after this. Similarly, for building also, you can see that nowadays that your sky cappers, big building, they are also, you have to find out there is a most of the cases for earthquake that it goes actually lateral vibration. It goes lateral vibration. So that one actually it comes. So that also you have to measure. Not only that, nowadays, as I've told you, almost every week actually we get a call that what are the a particular bridge, whether a particular big trailer can go from one side to another side, because the bridge is very old, whether it can take or not. So these are the different kind of say load test, all those things you have to do. That also comes under structural method, you can say. So these are the different kind. Just I am talking actually for bridges. So this is the one particular one. I did it once actually, this particular one. And then we have actually your say that your say we call it actually the two ends we call it abutment, and in the middle we call it actually pier. So obviously the pier, all those things can be tilted. As I've told you, what is the tilt? It can be tilted also because of the water, all those things it may happen during construction. Sometimes it happens, for example, there are so many piles, but when one pile there is a certain problem, then what will happen? So those things actually we do that, or what solution to be given actually. So this is the one, another one, abutment and pier. You can see that we go the different kind of components of the structure. And for that also you have to find out during construction, even after construction, that deterioration, other things happens, then what to monitor, how to monitor. As I have told you in the very beginning, that is structural health monitoring, that is one part. That means you have measured something. Now you would like to see whether the structure is all right or not. Then how do you do it this particular? Say, for example, there is a building. Now you have measured acceleration, you have measured displacement, you have measured strain at different locations. And the thing is that, and you have done the analysis. So analysis, you are getting something, and measurement, you have got something. There is a mismatch. But you cannot say that analysis is wrong. You cannot say that your management is wrong. So that's why, that means there is certain parameters, maybe modulus of plasticity, maybe some kind of say section changes, that area or something, whatever way it has changed. Because of that, this particular one is not coming with the analysis. So that means you have to change it, those parameters, so that both of them will come at the same level, assuming that measurement is all right. There is some kind of error, there is some kind of noise, definitely will be there, but that particular one you have to consider. So for that, it is nothing but an optimization problem. One can do it with the conventional method, steepest descent, Newton's method, conjugate gradient, direct search, whatever you like. Or nowadays people are doing with the genetic algorithm, particle swarm optimization, and optimization, whatever we are familiar. That means people all are familiar. So we are also doing here, and that is actually in the model updating. Now, just coming to that one, say uncertainties in building process. Now, you know that concrete structures, whatever it is, that building, wherever you are actually your hostels or anywhere, whatever you do, so that most of the buildings nowadays reinforced concrete. If we consider reinforced concrete, this particular one, actually, if you see that concrete is the second highest material used other than drinking water. So this one, actually, we can say that one, it is made of cement, sand, coarse aggregates, and obviously water. So water actually very, very important. If you give more water, then also problem. If you give less water, then also problem. You will not get the required state. How to measure that we will say whether concrete is all right or not? We go for actually 150 millimeter cube that we test it, and then on the basis of that, we can say that whether that construction is all right or not. This one, your site, that you can see that center of excellence actually can come directly under this, that you say safety operation during construction site. That can be formalized. This one can come because, as you can see, there are so many roads open, there are so many things, and anytime there can be an accident, and it happens also. So how we can overcome that itself actually can be a very good candidate for this, directly for this center. Now, if you really see that reinforced concrete, that quality of reinforcement insufficient, formwork where we are doing the concreting, that itself is not proper, quality of concrete, these are the three major things. If you go further, that insufficient amount of reinforcement, insufficient quality of steel, insufficient elastic limit, bend, insufficient strength, wrongly placed reinforcement, the reinforcement, wherever you are using, for example, you have to provide at 125 millimeter spacing. Somewhere you are getting more, so obviously that is actually your wrongly placed. The cover, whatever you have to provide, that is also not given properly. That means I cannot just simply provide on the floor. I have to keep it inside, otherwise it will be corroded. So that's why cover is also equally important. Then formwork is not proper. Because of the formwork also, that structure may fall at the time of construction. Then insufficient quality of concrete. So insufficient quality of cement, polluted water, wrong or polluted aggregates, wrong additives, wrong mixing, wrong position. So that means so many wrong things, so many inadequate, so many insufficient things, but still structure stands. This is the tree structures, but means one can do it by the Bayesian method, but research other things we can do it actually here. So that also we do it. So insufficient quality of cement, wrong grade, wrong type, wrong fineness, wrong setting time, because the concrete, it takes some time to set. Cement, it takes some time to set. Maybe it's half an hour, maybe 45 minutes, and full setting maybe 10 hours. So like that, and then mixing also is not proper. So there are so many things that they are in concrete. And finally, but the very good thing about that, it still stands. You can see that. So that means we have to overcome all of them. Then only it works, and that we do it. So before we conclude that particular one, I have a few slides more. So there are few fundamental axioms of CoE-SEA. All materials have inherent flaws or defects. Let us accept it. That flawless or defectless, it is very difficult. Damage assessment requires a comparison between two system states. The way we get the pathological, that if you are all right, that means you have to be within this. Your cholesterol, your hemoglobin, your pressure, all those things, whatever you talk it, sugar. So all those things, there is a certain limit. Here also, you have to compare. Identifying the existence and location of damage can be done in an unsupervised learning mode, but identifying the type of damage present and the damage severity can generally only be done in supervised learning mode. The thing is that nowadays, actually, we are using AIML in structural health monitoring on the data, whatever we are getting. Sensors cannot measure damage. Sensors only can give you certain number. So you have to extract from the signal, that means your natural frequency, your mean, standard deviation, all those things. On the basis of that only you can, then you have to analyze that one data. And nowadays we do it sophisticated one, actually using Python. We use it actually your pandas, then that you said so many actually packages we actually use it for data science. Without intelligent feature extraction, the more sensitive a measurement is to damage, the more sensitive is to changing of person and environment condition. This is your another one where we work. The length and timescales associated with damage initiation and evaluation dictate the required properties of the SHM sensing system. There is a trade-off between the sensitivity to damage of an algorithm and its noise rejection capability. The size of damage that can be detected from changes in system dynamics is inversely proportional to the frequency range of citation. Finally, damage increases the complexity of a structure. A structure, initially it may be linear, but because of damage, it becomes complex. It is very difficult to analyze also. So towards the end, I can say that in summary, my experience, my knowledge, I can say there is no single test by which one can find the damage. It will be a set of tests, results of which may be erroneous or noisy to be used for feature extraction. There may be multiple features conflicting each other. It happens in our daily life, in our health also. SHM should not be viewed as a damage detection method. To diagnose a disease, the doctor tries to find out different features. It is equally true for structures. Different type of structures behave in a different manner. Each type of structure is to be dealt with separately, like diseases applicable to different ages, gender, etc. Therefore, that problem nowadays hops from inverse solution. This is a damage detection is nothing but an inverse problem. Inverse solution, so statistical pattern recognition, which will eventually direct towards a particular disease. That means we have the way we consider the disease, that way also we can consider here you have to have a different solution. So in summary, let us accept sensors will give us data with noise as a free gift. Controller will not work with 100% efficiency. One should not rely on a single method. Judgment should be made on results of different methods, assuming they are not giving the full information. Obviously, you will not get up. There are certain kind of error will be there. We should not restrict ourselves in damage detection only. A systematic method should be developed for infrastructure asset management. As I am telling you that one, the structural health monitoring, don't say that, you call it infrastructure asset management, and possibly now the Center of Excellence actually very much comfortable with this one. So that is the one I can say, and it is now the transition phase going towards cloud-based wireless system. That way you can say. So that is the end of it. Finally, at the end, with this particular figure, this is my infrared photograph. As you can see, nowadays we do in the structural health assessment also, monitoring also. This is the one that different color means actually different temperature. As I am taking tea, that is very hot. That's why you have a different color. The faces, okay. With this, thank you very much. Thank you for listening. So if you have any questions, I love to answer if I know.
Sir. Yes, sir. Thank you, sir, for this wonderful presentation. Now we have several questions in the chat box. I'll take one by one.
Okay.
So our first question is, how are hazard risks like risk of fire, earthquakes, floods, etc. built in the structural health of a building?
Say, for example, generally at a certain, up to certain level, say, for example, we generally consider, I have actually my program, the name of the program actually DWELL, DWELL, dead load, wind load, earthquake load, and live load. So that means we always consider these 4 loads. The self weight of the structure, live load means the superimposed load, like say your furniture, all those things, including us. And then we consider wind load. Say, for example, whether you will consider, say, for example, coastal areas, maybe we can take, say, 180 kilometers per hour, that one we can say. And similarly, earthquake, because in earthquake, that one we are having actually now 4 zones. Actually, you have zone 2, zone 3, zone 4, zone 5. The Kharagpur actually in zone 3. Similarly, that your Himalayan areas is zone 4, Bhuj, other places, that one you can say zone 5, that we generally consider. So those things we take care. Fire also dependent on that hazard. Say, for example, whenever you are going for a nuclear reactor, for nuclear reactor, that one obviously that it will be very, very high priority. So that one will be designed in a separate way. So that even say, for example, particularly in Japan, it is a very much earthquake prone area. So because of that, their nuclear reactor, all those things actually they have considered with that high earthquake zone. So that way actually we take care actually at the time of design.
Yes, sir. Thank you, sir. So our next question is, what kind of IoT applications can be built to monitor the hazard risk in a building apart from fire?
This is very actually the thing is that this IoT, because just only I have given you one slide, because the thing is that I have shown you one slide. Just a minute. So as you can see that Raspberry Pi, if you are familiar, and Internet of Things, that one also comes actually, even say small Raspberry Pi can be actually used as an IoT. Even you can use, say, you can go for dedicated one, you can go for Arduino also. So the thing is that here, say for example, if you have, say for example, nowadays for a residential complex, say for example, you are having 20-story building. Now you require certain kind of IoT also, because the thing is that if you don't, say for example, somebody is residing at 20th floor and he has to communicate with the control room. So obviously that only phone is not sufficient. You require some kind of IoT, at least the minimum one, say camera. And then you are having, say, smoke detector. These are the two things you should have, so that directly from the control room one can see that what is the condition of that place. Other than your, say, structural health. These are the very common nowadays. The camera and smoke detectors very common. And nowadays also you can find out on the road also, you can find out, say, for air pollution, humidity, temperature. These are the three things actually you can see. Always it is installed in all three in together. And that directly it can be actually, nowadays I feel that it can be cloud based, and I personally feel, and Professor Maiti, that we can actually have something cloud based thing, and I can definitely, I have, which can be developed in house. Because the thing is that here, that if you can have data, and today you are having data, and that data you can actually sell that one to the same client in tomorrow or day after. So this thing actually we can think of it actually in an institute level. Yes. What is the next question?
Yes, sir. Thank you, sir. So next question is, what are the preventive and mitigative control measures which can be used to restrain creep?
Okay, there are two things are there. One is called actually creep, another one is called actually shrinkage. These are the two, particularly for concrete. So creep and shrinkage there. Obviously, that most of the cases actually we generally take care at the design level. That if you consider your concrete, generally we consider that one at the time of actually construction of how much actually your reinforcement to be provided in which location, so that creep will be minimized, that particular one. And apart from that, actually, if it happens, because generally it happens due to deflection, so some kind of deflection sensors to be used, so that we can monitor that creep we can monitor.
Yes, sir. Thank you, sir. So our next question is, why is National Building Code made mandatory across country as central federal act and rule?
Okay, so the thing is that the National Building Code having so many sections. One of the sections also we can consider fire also. There are so many, say, earthquake, wind, all those. There are different codes, and all those things coming actually under one, that National Building Code actually, that one. And obviously that is one actually formalization that everybody across the country they will use actually here, that code. I particularly IS code, Indian Standard Code, that they will use it actually. Because otherwise that how will, say for example, what type of load we shall use. Say for example, for residential building maybe say 250 kg per square meter will be sufficient. Say for example, if we go for, say, classroom, for classroom 250 kg will not be sufficient. We have to go for, say, 400 kg per square meter. So those type of things, for I'm talking for load only. Similarly for fire, similarly for earthquake, similarly for wind also. So for different location, you are having different values. So those things actually you get it in national building.
Yeah, thank you, sir. So I'm taking the last question for today's session. So it is about coal-based power plant in Haldia. The question is they are telling due to corrosive weather, in steel, the steel structures get corroded. Every year painting is done, but it also cannot prevent the corrosion. So how to ascertain the stability of steel structures which will ensure us that no collapse of structure occurs in future?
Okay. So first of all, regarding this, I can say that since it is steel structure and obviously it is near seashore, obviously that corrosion will be more, there is no doubt. At the time of design, what you have to do actually this particular one, that first of all, that your thickness of sections are supposed to be taken more. Thickness of section. Say, for example, where you can say 12 millimeter steel plate may be sufficient for a normal situation. Maybe you have to go for say 16 millimeter, so that you will so that your anxiety will be less. And painting, obviously, regular painting, that is important. So this is the one actually I can tell immediately. But only thing that for a particular structure, how it is behaving, that then only I can tell the proper one. But just simply looking at the problem generally that at the near the seashore actually, so that generally it comes that you have to give more that thickness of the section either for the flange or for the wave, that you have to give more whatever section require, maybe 2 or 3 millimeter more generally, because after 12 millimeter generally it comes 16 millimeter. That's why I told that 16 millimeter, maybe it can go 20 millimeter like that actually. So that is the way you can take care, that way only you can control.
Yeah, thank you, sir. Now, I would request Professor Maiti to formally provide vote of thanks to our expert speaker.
Yes, thank you, Professor Tang. In fact, it's a wonderful lecture. I am seeing the excellent presentation. Lot many issues, such a simple but effective manner you told to us, and I can still recollect that all those things what we have learned earlier days and reinforced learning kind of things. It's and you touched upon everything. You touched from the history of the civil structures, lifeline, neck to lifeline, then your planning and design codes, then the visual inspection, then finally the structural health monitoring, all the details starting from the data collection to analysis to prevention, what not, within 1 hour of time. Hats up to you, Professor Dag, because it shows the level of understanding and level of competency you have in this particular domain. And I'm sure that the participants got huge today because it's a huge mathematical subject, but still you have not used mathematics. At the same time, you have given us the understanding that there are a lot of mathematical things are there, a lot of analytics, statistics, machine learning issues are there. And your I also noted your some of the suggestions, particularly when you are talking about that construction safety site as well as cloud-based platform from the structural health monitoring point of view, where if we can develop such a lab, and definitely with your help, we will try our level best. But we request you to give some more lecture in some of the coming weeks in this particular domain, maybe some application side also, because I'm telling you, you solve many of our queries, many of our questions, many of our concepts you have cleared today. Hats up to you, sir. Thank you so much for your that kind presentation, as well as so much that effort in preparing and demonstrating the subject. Center of Excellence wholeheartedly that thank you for your this support. And obviously you are one of us, so I have no problem, so that I will get your help all the time. And I'm sure the participants got more than they expected. And thank all the participants for joining every weekend. And obviously, our moderators, Swin, Ashish, Sobik, and other research scholars and project staffs who are silently working at the back end and making the Weekend Talk wonderfully successful. With this small note, Professor Dan, I am saying I have no joy. I don't know how to show my joy and pleasure after listening to your lecture. But yes, I am extremely benefited. And I fully believe the participants are also heavily benefited from your talk. Thank you, sir.
Thank you. Thank you.
Thank you, sir.
So now we can formally close the session. We will meet in the next lecture again next week with one industry speaker. Thank you so much, everyone, for joining the session. We expect you will again join in next Friday. Thank you. Good night.
Okay.
Thank you, sir.
Thank you, sir.